Good day, stat students. So we're going to do section 9.2 part 4 today. So that's the third and final hypothesis test for the population portion P. So an adoption agency wants to investigate if the proportion of all children that is adopted within 1 year after arriving has changed. That's a clue of what's going to happen here from 3 years ago when that proportion was 0.24. The agency randomly selects 150 children over the past 3 years and finds that 45 were adopted within 1 year after arriving. Run this test at the 5% significance level. Okay, how do we know we're conducting a hypothesis test? We've stated that several times. Okay, what's our variable? Child was adopted within 1 year after arriving. Okay, meaning was the child adopted? Yes, no. Now, things don't always have to be yes or no. Remember, they could be, favorite color or any kind of categorical variable. Okay, when you're testing the population portion P. Okay, a lot of our, I think all of our hypothesis tests have all been yes or no type answers, but remember, any kind of categorical variable would do. Sample, 150 children at this agency was taken a look at, so n is equal to 150. That means the population must have been all children at this agency. What would be a success? This is a real good thing here, right? Finding a child that was adopted within 1 year after arriving. Okay, let me get my pen out. So how many successes did we have? We had, looks like, 45. So what can we calculate then? P hat, the sample proportion, the proportion within our sample that of children that were adopted within 1 year after arriving at the agency, right? And you put that in your calculator, okay? Turns into 0.3 or 30%. There's our background information. Let's run through our 5 steps. So step number 1, state the hypotheses. What are we going to probably start with? The alternative. Let's see. So we're going to test if proportion from a certain population has changed when it was 0.24. So what does that sound like? That sounds like P should be not equal to 0.24 then. What is the null going to be? Equal to 0.24. So P is equal to 0.24. That means P sub 0, 0.24. Clearly we're running a two-tailed test here, right? We know that we're running a two-tailed test because we have a not equal to sign. Okay? And we are testing what? Both less than and greater than at exactly the same time. What's that going to affect when we calculate our probability value, the p-value later on? Step 2, check the conditions. Random sample was taken. We got to verify the central limit theorem. Remember, for a hypothesis test, we got to do this stuff in here. Okay. So we got here 150 times 0.24. Remember, 0.24 was the value of the null. So that turned out to be 36. That's greater than or equal to 15, check mark. This calculation turned out to be 114. N times 1 minus P. 114, which is greater than or equal to 15, check mark. Central limit theorem implies the sampling distribution of p hat is approximately normal. That means we can use that formula right here to calculate our test statistic. If I went too fast there, please stop it and do all the calculations. Make sure you're comfortable with them. Okay. Here's our test set though. Maybe pause the video. Maybe fill in the values for the test statistic here. See if you get what I get. Don't do any rounding if you can help it. Okay, so remember, there's a null and the alternative hypothesis, P sub 0 is 0.24. P hat was 0.3. So we got here, I got 1.72 for the test statistic. Okay. So what does that mean? That means that the sample proportion p hat is 1.72 standard errors above the value in the null hypothesis. Okay, so hopefully that is getting to be a standard thing that you think about. All right, calculating the p-value. Now that's here. We got to take into consideration that we have a two-tailed test. So there's our test statistic, and so remember that we have a two-tailed test here. So what are we going to have to do? Oh, that was an ugly, ugly straight line. But we're going to have to deal with it here. So here's z, here's 0, here's 1, here's 2, here's 3, negative 1, negative 2, negative 3. Okay. So 1.72, maybe about here. Draw a line, it's right about there. We'll draw a line straight up. So we have this area to go ahead and calculate. But remember, that is not our p-value here because we have a two-tailed test. We have to calculate something as rare as that on the other side because we were testing less than. And so what's as rare as 1.72 and negative 1.72, which is maybe about right here. So these two areas are supposed to be the same. Sorry that they're not. Okay, that they don't look the same. But these two areas right here are the same. And remember what I told you. You should probably just look up the negative side of things, negative 1.72, when you have a two-tailed test like this. Okay, so let's go to our standard normal table and let's look up a negative 1.72. So a negative 1.72. What do we get here? I got here 0.0427. 0.0427. So we know that area is 0.0427, and we know that this area over here is 0.0427. So that means that you add these up or you multiply one of them by 2, and that looks like to me 0.0854 for our p-value. Okay, so conclusion. All right, so I think we're going to be running into this situation here. Let's see. So remember, don't accept the null. Okay, we're going to say do not reject the null. So the p-value is equal to 0.0854, which is greater than our 0.05. So we're going to say what? Do not reject the null hypothesis. So remember what I was telling you back in section 9.1. So we think both the null and the alternative are both still plausible things. They're still both possible, and we don't know which one is correct, and so our results are inconclusive. We don't know. Okay, we don't know which one's right. Okay, and so our conclusion is a little different now. Okay, but just slightly different. So when you say do not reject the null hypothesis, all we're really going to change here is that instead of saying that we have strong evidence, all we're going to say is that we're going to say we do not have strong evidence. That's our silly statistical way of saying we don't know. Okay, so instead of being really convinced of what's going on, we're not sure what's going on. And so instead of saying we have strong evidence, we're going to say we do not have strong evidence. The nots go together. Okay, and what do I mean by that? When you say do not reject the null hypothesis, that means we do not have strong evidence. Okay, so the nots go together. So we do not have strong evidence at the 5% significance level that the proportion of all children being adopted in the last 3 years has changed from 0.24. Okay, so we do not have strong evidence of that. We don't have convincing evidence at that point. Okay, and so we're not sure if it's basically this is what's going on, is that it could be greater than 0.24, it could be less than 0.24, it could be equal to 0.24, and we don't know which one it is at this point. Okay, and that's what's going on here in this particular problem. Okay, so that ends our discussion for this problem. Thank you.